The seventh demo says, explain the interaction between a negatively charged electroscope. How do I do that? I have to touch it. So I'm going to charge that electroscope negative. Not just have it detect negative, but I'm actually going to charge it negative. We did get all the way through.
Yes.
Okay. So I charge it negative. I put all that negative charge that was on this rod, or a lot of the negative charge that was on the rod. They want to get off this rod. So they run on the electroscope. Now, what's charge on the electroscope? Negative. I am going to recharge this rod.
Well, that's really staticky.
I'm going to recharge the rod. Prediction, 3 things could happen. Number 1, the rod can move back, or the arm can move back. 2, nothing can happen. 3, the arm's going to move more. So who thinks it's going to be 1? The arm's going to move back.
I remember option 1.
Arm, meaning the arm moves back towards the center. Option 2, nothing's going to happen. Okay? Option 3, the arm's going to move.
Option 4,
Let's see.
2.5.
Oh!
Wait, what?
Because they repel. Right?
Okay.
Negative.
The point is, are there negatives up at the top?
Yeah.
Yes. Are there negatives also at the bottom?
Yeah.
This entire thing has more negatives than positives. However, there still are negatives up on the top. When I bring this rod close, by the way, this is repelling down here because there's already too many negatives. When I bring the rod close, the negatives up on top, they're like, oh my gosh, there's even more of them around. They say, well, there aren't as many down at the bottom. There's still a lot, but not as many. So the electrons up at the top, they run down the electroscope, making the already negatively charged bottom even more negatively charged. Meaning the arm's going to sway more. And I can bring this wherever here, and the same thing still happens. So let's diagram that out. Now, if I tell you in a prompt that it's already a negatively charged electroscope, you do not have to show how it was charged. So I'm going to draw an electroscope. And it's already negative, so is the arm going to be upright?
No.
No, so we'll put the arm a little bit out. Drawing my positives.
Wait, the word it does move?
Pardon me?
Wait, I was looking for one drawing in this.
2 drawings.
Bad joke.
Okay?
What joke?
So, the electroscope is negatively charged. So on there I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 positives. So if it's negatively charged, I have to have more than 11. Now, are most of them down at the bottom?
Yes. No.
No.
No. When the rod is far away. If they were all at the bottom, where would they go? Where would some of them go? Someone would say, hey, there's a bunch of protons up there. Let's go up there. So what you're going to get is a fairly equal negative charge throughout the entire thing. It's not overwhelmingly negative anywhere. It's just equally negative everywhere. So I might put 5 up there, so that means, you know, every couple add in a couple more negatives. So net negative. And over here we're going to say far away. There is also a rod. Put it in your notebook. Okay?
Oh, yeah.
There's also a rod that is net negative. Okay? There's drawing number 1. Drawing number 2. The rod is brought close. Does that mean it touches?
No.
It's brought close. Now, What's our freebie? Protons. So I'm in the same spot. So I have 1, 2, 3 protons there, and somewhere in the range of 7 or 8 electrons. So I'm going to draw my electroscope. We know the arm moves more. Oh, by the way, here it already is repelling. Here now, we'll say it repels more. Repels more. My freebie, my protons. Okay. There's all these negatives up near the top. So where do the negatives that were at the top, or at least most of them, want? Or what do most of them want to do? I should say that. They want to get away. So we say the electrons rush down. They're not all going to rush down, but most of them will. I'll leave 1 up there, which means 4 are going down. Here's a point. If you're pretty close, you're pretty good. And there you go.